All right, so before I start, this is an amazing event, but we have also planned an official MongoDB event on May 13th here in Zurich. So if you haven't yet, please register for that one as well. There will be amazing talks. I will have a nice talk there about some stuff, but also one of our principal engineers will be on site, Asia Kamsky, talking about myths around indexes at MongoDB, which is really an amazing talk. If you think you know how indexes work at MongoDB, you don't know it, believe me. So we will show that afterwards again. Please register, don't be shy. This will be an amazing event in Careum Zurich, organized by MongoDB. And also from my side, big shout out to Peter and Juan for organizing this. This is really amazing to see a growing community in Switzerland around MongoDB technology. Okay, did you just import that into my slide deck? Okay, thank you. All right, so this is the hell of a title, I know, don't read it. It's something about AI. I will talk about that a little bit. Some words about myself. So I'm Philip, I'm an advisory solution architect for MongoDB here in Switzerland. I'm more than 4 years with the company now. I work almost on all Swiss accounts who are using MongoDB. That's why I know Peter, that's why I know Juan, and some people of you as well. And that's why I'm also amazed to see a growing community. I can assure you 4 years ago when I started, when MongoDB did an official apéro here in Zurich, there were less people at an official MongoDB apéro than today here. So it's really amazing for me to see that. So I will talk about vector search, of course, and what does that has to do, especially in the context of RAG, so Retrieval Augmented Generation. This is a super hype word about AI, and I will demystify that a little bit today. So the agenda is to first see what's all about LLMs, and then I will show you a little bit RAG in action. I have brought a little use case with me. I'm not so brave as Michi. I don't do it live, but yeah. And then I will show you how you could master the R in the RAG. R, retrieval. You can imagine that we are a database. Retrieval is our business. But first of all, a question. Who knows what an LLM is? Please raise your hands quickly. Yes, yes. 50%. Who has used ChatGPT already? Okay, almost everybody, I assume, huh? So, but what is really an LLM? Do you know how ChatGPT really works? Okay, let's demystify that a little bit. So what is a large language model? Essentially, it consists out of 2 files. A very small file, around 500 lines of code, could be C, could be Python, could be anything. And then there is some mysterious thing called parameters. And these are numbers from the Llama 2 model, which is already obsolete. So this is one of the most documented open source models from Meta. The Llama 2 model is around 140 gigabytes of parameters. And if you install these 2 files on your laptop without any internet connection, you can start chatting with that. It generates text which makes sense, which is kind of a little mystery. Because what it does in the end, it just predicts the next word. Come to that. So how do we get these 140 gigabytes of parameters? What is that? So essentially, it's a chunk of the internet. Here it's written 10 terabytes. So this is 1 year old. Today it's 40 terabytes of pure text data downloaded from the internet. It's the Wikipedia, it's Redis, it's whatever you want, and then they let run around 6,000 GPUs for 12 days, costs around $2 million to do that, to generate a base model. And you can think about that, this is kind of a zip file of the internet. But zip is lossless, this is kind of lossy. And what it does in the end, it just predicts the next probable word. And this is what these 500 lines of code are doing. You put in start of a sentence, and then it just predicts the next word. So cat sat on A, it predicts 97% probability it's probably Matt. And then it puts this mat behind that, puts everything in, and predicts the next word. This is how ChatGPT is talking to you. It's a statistical model, nothing else. There is no consciousness or nothing. It's just predicting the next word. It even doesn't know what it's saying, but it makes somehow sense. So how does it work? So this is the transformer model, and this is out of a white paper generated by Google engineers, which made the breakthrough in training big models. So we know machine learning since the 80s. But the big breakthrough was in 2018 when there was a white paper from Google engineers. It's called Attention is All You Need, where this transformer model is described, which allowed us to take really big chunks of data and generating really big parameter files. But little is known in full detail. And believe me, I had this talk several times in front of 50 or 60 IT professors at universities. They tell me exactly that. Nobody knows exactly how these billions of parameters disperse to that network and generate some sense. Nobody knows that for sure. We know how we can iteratively make it better, but we don't know how it really works. We can measure that it works, yeah, but as I said. So, and you can think about that as this is kind of a knowledge base, but it's a little bit strange and imperfect. So it hallucinates, maybe you have seen that. Try shortages, abbreviations, ABC, what does that mean? It always finds something what that means. And it had also some flaws. So this flaw is already fixed, but this was a viral example. For example, you could ask GPT-3, who is Tom Cruise's mother? And it knew it's Mary-Lee Pfeiffer. But you could ask, who is Mary-Lee Pfeiffer's son? It didn't know. So this was GPT-3. Now they trained it better. So iteratively, it can get better. But at the end, we still don't know why this makes sense, what comes out of these models. But it has a big impact on our society already. So schools need to rethink a lot. But if you want to know more, I can highly suggest you to scan this QR code. This points to a YouTube video from Andrej Karpathy. So Andrej is one of the founders of OpenAI. And then he went to Tesla and he founded the Tesla AI division, building the self-driving cars. And now he's back to OpenAI. So he is really publishing very, very cool videos explaining the details how that works. So if you're interested in that, he recently added a new video. It takes 3.5 hours explaining the whole training process of a base model, which is amazingly cool explained. So after that, you know, this is no personality. It will never create a personality. It's just a statistical model. Okay, having said that, what if you ask ChatGPT about the top 3 songs in 2023? So it brings these top 3 songs because it's trained on that, it knows that, and it brings that back. So, but what if you ask ChatGPT about, do you know my personal top 3 songs? It hopefully answers this way. Don't know. Because yes, of course, it has no access to my personal playlist. Not yet, at least. So, but what if you could augment that with your own data? And this is exactly what I want to talk about. So the question then is, which information do you provide to this chat model to make it better? So yeah, well, the answer is obvious. Must be data which is relevant to the question you ask. But okay, how we will know which data is relevant? This is where these R part or where vector databases are coming in. So first of all, I need probably to tell you what is the difference between a database and the search engine. We saw it in Michi's Terraform talk already. So search is something different than a regular index. And on MongoDB, this is the same thing. If you use MongoDB, you have the database itself and you have kind of a search engine. And the database is very good for exact matches. You can search for a user ID, You could search, you don't know, a zip code or something like that, and it will return you the exact match. So no hallucination there. A search engine is a little bit more fluffy. You don't know exactly what to ask. For example, you could ask in what movie were Harrison Ford playing archaeologist, and it brings you always back a result, but it is sorted by scoring. So how good does the database think this result matches to your query? And a vector query is the same thing. But the question is, what is a vector? Do you know what a vector is? Nobody? Have you ever worked with a vector? Yeah, for sure. Everybody of you has worked with a vector. Why? Because, yeah, a vector is a series of numbers. Like this one is a vector. 0, 1, 2. Or this one could be a vector as well. Or this one. Or they could be much, much, much longer. And what can vectors do? They capture meaning. They don't capture the exact words, they capture meaning. And as I said, I'm pretty sure everybody of you has used vectors already. Right here. Red, green, blue. This is a vector. So if you define a color in your Word document, you use a vector. Because this is black, this is blue, orange, and so on and so forth. So what is a vector embedding? A vector embedding, yes, it represents meaning. So for example, this sentence here, I listened to Beyoncé, turns out to be lots of numbers. And we don't know exactly which number means what. This is, again, the mystery. It's the same as in language models. That could mean this is a female, this is a singer, this is listening. We don't know. But they represent something in a multidimensional space. And how do we get these vectors? So yes, you have some data, and then you have an encoder, and these encoders will generate vectors, and encoders are kind of the cousins of these large language models. So OpenAI is providing something, there is from Llama something, so Hugging Face has lots of things, and there are coming, I would say, more or less every day there is a new embedding model coming up. They're trained a little bit different, so they're using this BERT. So here we have a sentence which starts, and there is how are you doing today? And now we mask one word, and the goal of the training is to guess that word. And this is how these vector embedding models are trained. So U has the highest probability, and this will generate these numbers in the end. And what they do, they can represent coordinates in a multidimensional room, and you can add them together. For example, woman and queen is close, king and queen is maybe also close. So there are different distances between these words, and they build clusters in your data. For example, these probably are singers, these are technologies, this is food, something like that. And so we store these vectors, but they are in a high dimensional space, and this is super hard to display on a slide. So they start by 300 dimensions, they go up to 4,000 dimensions. This is not visible displayable, but you can imagine in the math, you can calculate distances still. So what does that has to do with MongoDB? So MongoDB introduced vector search capabilities as part of their search engine more than 2.5 years ago. This is something I bring from the field. And one thing I can say is these foundation models are sometimes super different. And you could read all these white papers around that and find out which foundation model is the best for your use case. And after you have read all these white papers, there's a new one, and you can start from the beginning, or you can just talk to these models and try out, is it answering the questions my customers potentially have in the best way? And you should also think about a language model as it's kind of a little child. So the prompt design is super important. You need to be very precise what to tell it. The more precision you give in, the better precise results come back. For example, I took the SBB Q&A page, And this is now where I should do a live demo, but I'm too shy. So when I search on the SBB page, for example, what can I do with my Swiss pass? I get 75 results. But you see the first result is already not helping me very much. You will find answers to the most, I don't know, in a mobile app. So it doesn't work. So what you can do, you could encode all these Q&As in the database, and then it would look like this. So you have your document, here's the question, here's the answer, here's the URL to the original Q&A, and then I send that to an embedder, and I just get back a bunch of numbers. And I store that in the document itself. And this is the beauty of the document model. You can embed the embeddings, which sounds a little bit awkward, but it is the way it is. So in the end, for the database, it's just another field holding, in this case, 1,536 double numbers. And then, we have seen that in Michi's demo, you create a mapping. And instead of saying this is text, you say in this path, so if we go back, the field name is vector underscore embedding. Here are the numbers. In vector underscore embedding, you will find 1,536 dimensions, and you use the similarity algorithm Euclidean. There are several similarity algorithms. They measure the distance between points in a different way. That's what you need to do, nothing more. And now you can ask the question to both, to the base model, and you can ask it to the database at the same time. And the text you enter here, you pass through the same encoder. And it will create also a bunch of numbers. And now you can create a query. And this is how the query looks like. So you do a vector search, and here's the query vector. This is what gets generated here out of that text here. It gets generated, and you put it as input. Again, the path is vector embeddings. You say, okay, examine the 100 nearest candidates, but give me only the 3 top results back. And then you can create a prompt for your language model. And the prompt looks like this. So this is really what you write and what you send to ChatGPT now or to any other language model. Using the following information from multiple sources, summarize the key insights while prioritizing the most relevant findings. The information is provided with a source and a relevance score. So you tell the language model what you will provide, and then you give the combined context. The combined context has the source and the relevance score, and then the original question out of the user input in clear text, and then please follow these instructions for your response, and you give some instructions how you would like the response structure. For example, use markup language, avoid referencing specific services directly, and so on and so forth. And if you do that, you get exactly that answer, which is much, much, much more precise than if you would just ask plain ChatGPT or other models. And you get also links to the sources where you can point to the original web page. So the beauty of that, implementing such a solution is work of an afternoon. But everything which is too good to be true is not true. So the other thing is true, you can do that, but what if your data looks like this? A knowledge graph. Or if you have data like this in an already structured way. So language models can work very well with unstructured, just with text. But here we have very precise information, for example, a price and so on. And the question could be, how many notepads cost more than $30? If I just pass that into a language model and ask that question, you probably get not the right answer, because language models are very good in language, they're very bad in calculating stuff. But you can do something different. You can create another prompt. Generate a MongoDB query to answer the following question, use the provided sample document as reference, give it a sample so that it knows what to do. Question, how many notepads cost more than $30? Make sure the query is optimized and specific to the given document structure. You need to tell it. It doesn't assume automatically. It's a child. And actually, this is quite a good query coming out of that system. This is actually answering exactly that. So it does a match, which is good. You should always have a match in your aggregation pipeline. First stage, first an unwind is bad. A match, narrowing down the result, do the unwind, then again a match on the unwinded structure, and then grouping, and then you get everything. Okay. Also, the embedding model could be very important. There are different embedding models. They are trained on different data sets. They're also trained on specific industries. And they have particular skills. And you can make use of them. So if you look at Hugging Face, there is a top 10 list of embedding models. This changes every week. There are really super specific models. Again, you can read all the white papers and all the benchmarks, but you can just pick some and try some on your data and see how they behave. This is also important. So there are, I said, different similarity algorithms. At the moment, we support Euclidean, dot product, and cosine. This is how they measure the distance between points. So sometimes they measure the distance, sometimes they measure the angle and everything. And keep your vectors quick updated. So it's good to have vectors in a separate vector index to keep them asynchronously updated, but fast. For example, here, sample architecture, you have lyrics in your database, song lyrics, and you want to have tags and vector embeddings created. So you have your document store, you have your vector search index, but you have also Atlas stream processing, maybe you know, which could fire data to a Kafka connector. Then you use Confluent, which is also a nice cloud service. And Confluent will split that up. For example, you have Spanish and English input topics, and Spanish and English specialized tag extractors, which will extract the tags. And then you have Spanish and English specialized embedding models. They send that back, you store it back to your database, and your vector search index gets updated automatically. So this one is synchronous, and this whole thing happens asynchronous, but in the most efficient way. Filtering is also a good thing to do. So, you know, text embeddings are trained on a large training set, but you might have in your data set, in your small data set, compared to these 40 terabytes of text, you may have special terms and nonces, user IDs maybe, or something you search which the model is not trained on. You can actually add pre-filters to the vector search. So in this example, we have this Mflix movie database. So we're searching for a plot, and we have the query vector, but we only search inside this range of years. So this has two advantages. It narrows down your vector search, which makes it much quicker. And it also makes the result much more precise. So you can filter on surrounding meta information, but you can bring it one step further also. So there is one thing which looks super promising, and this is really a cool thing. It's called hybrid search. And what does hybrid search do? So we found out with talking to lots of customers that embeddings or vector search is actually super great at short text. If you throw a full PDF at it, it gets confused sometimes. So what you can do, you can take a document and, for example, split by paragraphs and embed each and every paragraph separately, and use full text search on the full document or on the full page, and use kind of an information to group. I use here the page number. You could use the document ID, whatever you want. And because MongoDB is polymorphic, you can put everything in one collection. So here we have the paragraphs with the embeddings and the page number, and we have the full page content with the text and the page number. And now you can fire two queries at the same time. It's the same aggregation pipeline, union with in between. You fire the same query with vectors and with full text. You get back two results, and you merge the score. And you can see here I penalize the vector score by a factor. And here in these lines, you can see which one has the most influence on the search result. And you can see it actually switches. So the search term here is future flying machines. And depending on what is more relevant here, full text or vector search, the results shift. And you can play around with that and see how much this drives the precision of your retrieval. There's amazing stuff coming up as well. So maybe you have realized Mongo has acquired an AI company 2 or 3 weeks ago. It's called Voyage AI. It's a startup from the Silicon Valley having the best ratings on embedding models, because the main thing is AI has a trust problem. Nobody trusts AI 100%. And if you can drive the trust upwards towards this 99.9 something, you will never have it on 100%, at least this is my opinion. But if you can drive the trust upwards, this is definitely a game changer. And Voyage AI has the best embedding models, considering benchmarks, and they have also so-called re-rankers, and they have industry-specific re-ranking and embedding models, and you will see magic things happening in Atlas. At the moment, you need to do this embedding calculation stuff manually. Okay, it's just some lines of code, and there's a very great LangChain integration, for example. But you can expect that you can define in Atlas in the near future, this is my text field, or these are my text fields. I want to use this embedding model from Voyage AI, and it will automatically generate the embeddings. This is my query in clear text. It will send it to the embedding model and resolve it for you automatically. So this is where the Voyage goes. And this is it. So thank you very much for watching. Pizza is not here yet.
No.
So I was in time.
You're too fast.
But happy to connect on LinkedIn. Happy to see you. Let's go back to the first slide. Happy to see you on the MongoDB day in Zurich, 13th of May. And happy to have a beer and a pizza together. Thank you. And yeah, if there are any questions, anytime.